everyone. In this video we are going to solve the differentiation worksheets. These are from paper like pure maths 2 from A levels. Okay, this is P2 of A levels. So we'll start. I think on your book this is chapter 8. The worksheet is entirely compiled with your question papers. They have questions from the recent paper and also from the old papers. This is like a combination. Okay, I think this entire paper will have like 10 questions, 10 to 11 questions over here, and we're going to solve each question within this video. So let's start. Now problem is I do not have space over here to solve these videos, like solve these questions, so I'll be taking parts of this question and solving in the other PDF. Okay, now in question 1 it says that this structure, which we can clearly identify, this portion is a rectangle and the other portion is a semicircle. Right, so I'll just label it with alphabets for my easiness of the explanation. So this is point A, B, C, D, D and E. So we can clearly understand A, B, C, E is a rectangle, whereas your E, C, D, E is a semicircle. And obviously the 2x is going to be half of that, like the radius of the semicircle is going to be just x meters, right? Okay, now again it shows that figure 3 over here shows the plan of a stage in the shape of a rectangle joined with a semicircle. The length of the rectangle is 2x meters, wide is y meters, and the diameter of the semicircle is also 2x meters, and the perimeter of this entire thing is given as 80 meter. Now it says that show that the area of that a meter square on the stage is given by this. Okay, area for this we can clearly understand. We just have to use the formulas for the rectangle and semicircle. Now I do not have much space, so I need to use a different page. 1 minute. Okay, this is like the solving for that file, so I'm going to consider this. Wait 1 minute, do I have that file open? Okay, so this is question 1. Now I'll just keep a heads up for that statement which we were trying to solve over here. So I'll just take a picture of this and then solve it. Okay, now I can clearly understand the area of a rectangle is going to be what, 2x multiplied with y, and the semicircle is going to be just pi r, right, because it is half of a circle. So for this case, area is going to be rectangle plus semicircle. For rectangle you have 2xy plus just pi x, because radius over here for the semicircle is x, so pi x. Okay, the problem is there is over here in the given equation for your area, it doesn't have any y involved, right? But on your equation you have this y. What this means that you have to use this perimeter over here to find out a second equation in terms of y. So this is your equation 1. Okay, and then again I'm going to find out the second equation in terms of y over here, which is going to be I already know the perimeter over here is going to be what, 2x, y, and this half circumference of this semicircle. So for this perimeter, I'm going to write it down as 2y plus 2x plus this circumference is what? Sorry, what? 1 minute. We were trying to find out the area over here, right? Sorry, I forgot. Over here it's going to be half pi r square. So in this case we're going to get half pi x square. For the circumference, now you're going to write that for total circumference of a circle it is 2 pi r. For half of that we have to divide this with 2 gets cancelled out, you just get pi r for the circumference, which means now you can write just pi x is equals to 80, because we already know the perimeter was equals to 80. Now we're going to just make y the subject of this equation, which is going to look like y 80 minus pi x minus 2x. This entire thing will be divided by 2, right? 80 minus pi x minus 2x. Yeah, this is what your second equation would look like, and obviously after this I'm going to substitute the second equation into the first equation. This is how the equation looks like. Substitute equation 2 into equation 1, which is now going to be 2xy half pi x square. Area, previously you got 2xy plus half pi x square, and instead of y we're going to now introduce it to that equation, which was 80 minus pi x minus 2x over 2 plus half pi x square, which certainly means these two gets cancelled out, and this entire expression will then be multiplied with x again. So now you have 80x minus pi x square minus 2x plus half pi x square, which again this and this can be cancelled out together or added together. Minus pi x square plus half pi x square gives you minus half pi x square. So it's going to be 80 pi minus half pi x square minus 2x. Now again, if you go back, your expression was written as over here it's going to get x squared also, because x will get multiplied with 2x, right? We're just going to get x over here common, so which is going to be 80 minus, if you take x square common, but at the end this is how it's going to look like. 2x square is just going to be positive 2, and then again half pi x square is going to be positive pi by 2. We can write it down like this, as we have took minus over here common in the front of this bracket, right? So everything will be multiplied with the minus, and everything will return back to its minus signs. So this is how the expression would look like, and this is what the expression was supposed to look like according to your equation 2, right? 80x minus bracket 2 plus pi by 2, entire thing with the combination of pi square. So this is approved maths. We have did this completely fine. Now we're going to move on to the second part. Like all these things, area, perimeter, and the substitution working, all these things will get you the 4 marks. We're going to move on to the next questions. Use calculus to find the value of x at which a has a stationary value. Okay, now for this stationary value, I know that at stationary value, at turning point, at maximum point, at minimum point, the differentiation for that equation is going to be equals to 0, right? So they wanted to find out the value for x when area is equals to 0, when area is stationary, which means that differentiation of this area with respect to x is going to be 0 for this stationary point. So it's quite easy at this part. For part B, we're going to write that at A's stationary point, dA by dx is supposed to be 0. Okay, so in that case, differentiation for this equation is going to be 0. It's better to use in this format than use this format, right? Because it is like in a product format, you have to simplify that with the brackets and then get the equation, right? So it's better to write it in this way. Like a is going to be 80x minus half pi x square minus 2x square, and then I'm going to find out the differentiation dy by dx. 80 will be just 80, half multiplied with 2 is going to be 1, so you get pi x, and this is going to be minus 4x, right? This entire equation will be equals to 0, which means then we can take x common over here also, which is 80 minus x pi plus 4 equals to 0. At the end, you can write x pi plus 4 equals to 80, and x is eventually 80 over pi plus 4. Now in the question, it was never stated that you have to find the answer in decimals. I will actually like to keep my answer over here like this, because it gives you the most accurate value, right? So I'll think of it as the final answer, 80 over pi plus 4. That is the final answer for your x. This is the value for your x you get when a is at a stationary point. That means the differentiation with respect to x will be 0 at this situation, right? And using that situation, you got the value for x over here. Okay, now moving on to your next question, part C. For part C, it says that prove the value for x when you found in part B gives you the maximum value for A. Okay. Now, in order to prove that, this means basically you need to find out the nature of this value for x that you got, right? Because whenever your differentiated equation is equals to 0, that could be either this point is a maximum, this point is a minimum. Okay, you need to identify that if this is for the maximum or minimum. Okay, so I'll just draw a very simple graph to explain you this. For example, you might also have a quadratic equation to work with, right? And sorry, not quadratic, cubic equation to work with in some cases. And in cases for cubic equations, what happens is that in cubic equations they have this both points involved, right? This is the maximum, this is the minimum. Now how can you identify, like over here for this kind of situations, when you're going to differentiate differentiate the equation and consider the differentiated value equals to 0, you're going to end up getting two values for x. Now how can you identify which one will be the positive and which one will be the negative? You can identify the nature of the roots by double differentiating the equation. Okay, so first, you need to double differentiate the equation. After double differentiating the equation, whatever the value that you got, okay, from the first differentiation, you're going to input that value of x into the double differentiated equation. And if under using that value for x you got with the first differentiation, if your second differentiated equation with that value for x comes out to be positive, then it is for the minimum point. Then that value for x was for the x coordinate of the minimum point. And if using the x coordinate of the first differentiation gives you a negative double differentiation value, then it was for the maximum point, right? This is how you're going to identify the nature over here. Okay, so which means I'll just erase this a little bit, because or I think I should write a flow chart over here. In order to find out the nature of roots, what you do, first thing over here you do is that in order to find out the nature of roots, first thing you do is that dy by dx is equals to 0 and calculate the value of x. Okay, using the differentiation dy by dx equals to 0, you calculate the value of x. Okay, and after this, using the value of x, you're going to input this x into the equation for your double differentiations. Okay, use or input if now you get the double differentiation equation positive, this is for the minimum point, and if you get, using the value for x after inputting that into a double differentiation equation, if you get double differentiation equation as negative, then this was for your maximum point. Okay, now remember, in your question part C, they were actually asking to find out that how can you understand the value that you got for x, which was 80 pi plus 4, is actually the minimum x coordinate for this situation, sorry, maximum x coordinate for this equation. You can identify that by following these procedures, right? So the first thing first we're going to do over here, we already know when dA over dx was 0, the value for x you got was 80 pi plus 4, right? This is the value that you got for x when the differentiation or when area was at stationary. In order to find out the nature, you have to first find out the expression for the double differentiation. Okay, now what was the value for the normal differentiation you got? 80 minus pi x minus 4. Okay, d square y dx square, I mean originally this equation was 80 minus pi x minus 4x, right? Obviously if you double differentiate it, 80 will be entirely vanished from the equation, pi x will become negative pi, and negative 4x will just become negative 4. right? In some cases there are situations also like this when the double differentiated equation does not have any x. In that case it's just easier for you. You do not need to now input anything into the equation, right? You can just now find out, like I mean you can clearly see this is going to be a negative answer, right? Which is what, negative 3.142, negative 4. This is approximately going to be negative 7. I can clearly understand that from this equation already. Minus 7 minus 4, yes, minus by minus 4 is indeed giving you minus 7.142. so you get the double differentiation value as negative. So if you're getting the value for double differentiation as negative, this certainly identifies your value for x as pi 80 pi by pi plus 4 as the x, like maximum x coordinate for this situation. You can now see this is double differentiation is negative, therefore x 80 pi plus 4 is indeed for the maximum x coordinate. So maximum, right, since you got negative double differentiation, so this is for a maximum x coordinate, which is correct. Now after this they want to find out that what would be the value for the area, right, in this situation. Like obviously your graph is at the stationary point. Like for example over here, this is how they're actually referring to this situation. They have a in the y-axis and x in the x-axis. Now for this stationary point, right, you got the x coordinate as 80 pi plus 4, but what about the y coordinate, right? On the y coordinate they must have a value. Obviously at this point your dA by dx was 0. Differentiation for this situation was 0, but what about the y coordinate for this case, or you can say the a coordinate for this case, right? So you're just going to input that value for x into the original equation for your area. For part D, you just want to find out the value for area when x equals to this 80 pi plus 4. So for area it was, I think, 80x minus pi, I think it was 2 plus pi by 2 with x square. Right, now and in every cases we're going to write 80 pi plus 4, then 2 plus pi by 2 multiplied with 80 pi plus 4 square. We're going to input all these things on a calculator and find out the value over here for the last part, for the area when a was this value. Okay, which is going to be 80 divided by pi plus 4 and minus 2 plus pi by 2. This again gets multiplied with 80 pi plus 4 is whole square bracket. But you approximately get 488.079. We're going to keep our answer to 3 significant figures. So you get 448 meters square, right? Because area was measured in meters square. So 448 meters square. This is the final answer. I hope this was all clear to all of you. This is how you're going to do the procedures. Nothing else than this. Thank you. We're going to move on to the next question then. Right, in differentiation for pure maths P2, it's quite repetitive. It doesn't change that much, and that's not that much stuff also, I would say. So wait 1 minute. I'll again take a screenshot of this second question and then do it on the other file. Question 2. Now it says that you have this cubic equation. You need to find out the differentiation of this, which we can clearly understand. 3 will come in front, multiplied with 2 becomes 6, and 3 minus 1 gives you square. 5 comes in front, multiplied with 5 gets you 10, and 2 minus 1 is just 1. And then you have 4 to the power of 4x to the power of 1. 4 gets multiplied with 1, so you get just minus 4. Right, this is how the expression would look like, and 2 will entirely vanish because it doesn't have any x, and differentiation over here was with respect to x, right? So it will get vanished. Okay, and again it says that find using the result from part A, find the coordinates of the turning point. As we have already stated that in turning points, right, in turning points, stationary points, maximum point, minimum point, in all these cases your dy over dx is equals to 0. So we're going to use that concept over here. For part B, in this case, dy is equals to dy by dx is equals to 0, which is 6x squared minus 10x minus 4 equals to 0, which is eventually going to be, I'm going to split the 6 and 6x squared, 6x, 4x, 4, 0. Wait 1 minute. 6 minus 10 minus 4, 2 and 1 by 3. Okay, then I think you are supposed to split this using 12 and right, 12 and 2. So this is going to be 12. Okay, this is going to be 12 and this is going to be positive 2, and now it will give you the perfect answer, which is x minus 2 plus 2 is x minus 2, 0, 6x plus 2 and x minus 2, 0. That means from the first part we're going to get minus 1 by 3, and from the second part we're going to get 2. Okay, so 1 by 3 and 2, these are the values for x. Okay, after this, I mean, we kind of need to find out the coordinates, right? For for the coordinates, we also need the y coordinate, right? These are only the x coordinates for the turning points. In order to find out the y coordinate, I'll input these values for x into the original equation for y. So for the original equation of y was 2x cubed minus 5x squared minus 4x plus 2. So we're going to get, when x equals to minus 1 by 3, y is going to be 2 minus 1 by 3 cube minus 5 minus 1 by 3 square minus 4 minus 1 by 3 plus 2, and this entire expression will again be included with a positive 2, right? Because other value for x was positive 2 for the second turning point equation. So you actually get 73 over 27 for this part. So for the first case, the equation is going to be 73 over 27. And then again, if you do the same equation with 2 again, you're going to get minus 10. Right, so the coordinates for the turning points are first one is minus 1 over 3 and 73 over 27, and the second one is 2 with minus 10. Okay, now in part C, they want you to find out the double differentiated equation, which we can again do over here again. 2 comes in front, so becomes 12x and 10, right? Yeah, this is the double differentiation equation. Now you need to find out the nature of the roots, right? Nature of the turning points, which we explained previously. We're going to substitute the values in the double differentiated equation now, because now your double differentiated equation comes with x, right? In the previous part, when in the previous question, when we did double differentiation, the question rearranged in such a way that doesn't have any x for the double differentiation equation, right? So we didn't actually have to input anything on that part. But in this second question, they have this x over here for the double differentiated equation. Now we have to input the value for x into this equation. So I'm going to write it down over here, that for d square y dx square was 12x minus 10. So when x is actually negative 1 over 3, this d square y dx square is 12 minus 1 over 3 minus 10, and then again when x equals to 2, this d square y dx square is 12 2 minus 10, which is going to be 12 minus 1 over 3 plus 10, that is positive 6, which means this one must be the x coordinate for a minimum turning point. And if I do the same thing, wait 1 minute, I think, sorry, minus 1 over 3 minus 10, right, sorry, I made a mistake. This one was negative 14. Okay, and if I did the same thing with positive 2, now I get positive 14, which clearly distinguishes that this minus negative 1 by 3 with 73 over 27 is the maximum turning point, right? So this is the maximum, and the other one, this is the minimum, which is 2 with minus 10. Okay, in order to identify the nature of your roots, we only need nature of your turning points. We actually only need the x coordinates, right? The y coordinates are not needed. Okay, so yeah, this is it. This is how we're going to solve most of the maths in this chapter. Actually, for differentiation, they do not have that much variability. Questions would differ. I mean, the equations would differ every time, but over the time, the process is all the same, right? You can clearly see minimum point, find out the y coordinate, identify the nature. This is the same procedure for all the equations. Okay, we're going to do another maths, which is this one. Okay, now again in question 3, it says that a diesel lorry is driven from Birmingham to Bury at a steady speed of v kilometers per hour. The total cost of the journey in pound is given by this equation, and find the value for v for which c is minimum. This is the same procedure. You have to find out the differentiation for c, that would be equal to 0, and then you have to find out the value for v, which is quite typical at this point. We can obviously calculate that. For part A, I'll write c in terms of power because I cannot differentiate when these fractions get involved. So now we have 1400 v to the power of negative 1 plus 2 by 7v, which is going to be dc by dv, that's negative 1400, right? Because the negative 1 comes in front, gets multiplied with 1400, so it eventually becomes negative 1400. So with the power of negative minus 2, now minus 2 because we're going to subtract minus 1 from 1, so eventually we're going to get minus 2, and this one will be 2 by 7. Now this was a case for when c was minimum, which means that it was already given to you that dc by dv was 0. So this entire thing, differentiated equation, will be equals to 0. I'll write this over here as 1400 over v square is equals to negative 2 by 7, right? And I'll just make v square the subject, which is just going to be 1400 negative 2 over 7, and this entire thing will be inside a root, right? If you take that square on top of v to the left and to the right hand side, this is how it will look like. 1400 2 over 7, sorry, you get 70. The value for v when dc by dv, differentiation for when c is at a minimum point, is 70. That means over here the minimum velocity, sorry, the speed of v kilometers per hour, the minimum velocity that can be achieved with the minimum cost, for the minimum c is 70. Now they want you to find out the double differentiation and hence verify that this is indeed the minimum value. Okay, similar work. For part B, d square c and then dv square is going to be that minus 2 will come in front and get multiplied with 1400. So minus 1400 with minus 2 will be 2800. So 2800 v to the power of minus 3 this time, and 2 by 7 will entirely vanish. At this point, I'm going to input the 70 over here in this equation to identify if I get positive or negative values for the double differentiation. So that's 2800 70 to the power of negative 3, which is 2 over 245. That is actually a positive value, 2 over 245, and this is a positive value. And whenever your double differentiation comes out to be positive, obviously this means that this this point that you have included in the equation must be for a minimum point, right? So finally we have proved that since d square c dv square is positive for v is equals to 70, c is at minimum. Right, this is not the maximum, this is indeed the minimum coordinate then. Okay, and after this they want you to find out the minimum total cost of the journey. That means using that c, you're going to input that in the original equation and just find out the value for c. 1400 over v, 2v by 7. Okay, for part c it's going to be c 1400 over 70 plus 2v it was, right? So 270 over 7. That will give you the final answer, which is 1400 over 70 plus 270 over 7, and you're going to get 40. Now this is the minimum cost, right? Okay, now like every question is kind of in a similar pattern, so this is it. I'm going to stop the video over here. Thank you for watching. This is the differentiation for P2 Pure Maths 2 A levels at Excel. Thank you for watching. Bye bye.